In the previous session, we learned about the register codes in 8085 microprocessor. In this session, we are going to learn about the formation of opcodes in 8085 microprocessor. So without any further ado, let's get to learning. Coming to the topic that we are going to cover in this session, we are going to learn about how the formation of opcodes take place in 8085 microprocessor. Now in the previous session, we understood how the register codes are formed in order to access the different registers of the 8085 microprocessor. Now this was the basis of the formation of opcodes. Now in order to learn about the formation of opcodes, today I am going to use three different types of instructions, and they are MOV R1, R2, MOV R, M, and MVI R, D8. And the reason why we are taking these three different types of instructions is these are of different sizes. Well, the first instruction type, that is MOV R1, R2, falls under the category of 1 byte long instructions. Also, the second type, that is MOV R, M, falls under the same type, that is 1 byte long instructions. However, the third type, that is MVI R, D8, this specific type falls under the 2 byte long instruction. Now, in the formation of the opcodes, the register codes are going to play a very significant part. So we will need that as well. So let's begin with the first type, that is MOV R1, R2. Remember, these are 1 byte long instructions. Now, if you notice, this is just a type of the instruction. It's not a specific instruction. So we cannot form the opcodes for a type. We will have to form the opcodes for specific instructions like MOV A, B. So let's now learn how the opcode for this instruction, which falls under this type, will be formed. Now I hope you remember, in this instruction, B is the source and A is the destination. So we will begin with B. Now if you notice, in the register code chart, the code for B is 000. So in the opcode, the register code of the register, which is the source, is needed. We will also need the register code for the destination register. And in the chart, A is given the code 111. So let's have that as well. Now notice, from the 1 byte long instruction, we have covered 6 bits. We need 2 more bits, and Intel chose MOV to be 01. Now observe, these are 8 bits or 1 byte. Now since we have them in bits or in binary digits, in order to form the opcodes, we need to convert this into hexadecimal. And the conversion we also know how to do it. All we have to do is group the bits one nibble at a time from the least significant bit towards the most significant bit. So let's do that. Observe, if we consider the least significant 4 bits or the least significant nibble, it is 1000. Now 1000 in hexadecimal is 8, and the most significant nibble, it has got the bits 0111. This is going to be 7 in hexadecimal. So the opcode for the instruction MOV A, B is going to be 78H. Interesting, isn't it? How about we try out another instruction of this type? Let's take the instruction MOV E, H. So can you quickly find out the opcode for this? Let me show you how it will be done. In this particular instruction, H is the source, and in the register code chart, the code for H is 100. So let's have that at first. Then we have the destination, which is E, and E has the code 011. So we are going to have that as well. Now I told you earlier, Intel chose for MOV 01. So we will have the same code for MOV, that is 01. Now it is 8-bit completely. Let's group the nibbles from the least significant to the most significant bit. Now what do you think will be the opcode? Well, it is 1100, 12 in decimal, but in case of hexadecimal, it is C. Now what about the most significant nibble? 0101, 5 in hexadecimal. Therefore, MOVE, H is going to have the opcode 5C. So I hope you understood by now that with the help of the register codes, we can easily form the opcodes of specific instructions. And this is the reason why I have been telling you we don't need to memorize the opcodes for the specific instructions. If we know the codes for the mnemonics, with the help of the register codes, the opcodes can be formed easily, right? Let's now check out the next type, that is MOVR, M. Now this is again a type, it's not a specific instruction. So we will use one specific instruction for this illustration as well. Let's use our very familiar one, that is MOVA, M. Now for M, within the register code, the code is 110. So let's have the code for the source, that is 110. Now the destination is A and the code for that is 111. We are going to have that too as well. So we have covered 6 bits and we again are using the same mnemonic MOV and the code we already know for this is 01. Now grouping the bits 4 at a time from the least significant bit towards the most significant bit, we can easily figure out the hexadecimal equivalent. This is 1110, 14 in decimal, that is E in hexadecimal. On the other hand, we have got 0111, which is 7 in both decimal and in hexadecimal. Therefore, the opcode for MOVA, M is going to be, yes, you guessed it right, 7EH. I believe you are finding it very interesting. Let's try out another one, MOVB, M. For M, as we have seen, the code is 110, so we will have that. Now what is the code for B? Find it out from the register code. It is 000. So let's have that as well. Now we are again using MOV, so it is 01. Let's group the bits 4 at a time from left to right. Now 0110 is 6 in both decimal and in hexadecimal. And here we have 0100. So it is 4 in both decimal and in hexadecimal. Therefore, the opcode for MOVB, M is going to be 46H. And I believe you already have noticed, this instruction type is of 1 byte long and both the opcodes are of 1 byte long as well. 2-digit hexadecimals are nothing but 8 bits. Let's now move on to the third type, that is MVIR, D8. Remember, it falls into the 2 bytes long instructions category. Now once again, this is just a type. We need specific instructions to form the opcodes. Let's have the instruction MVIA, EAH. Now Intel specifies the code for MVI to be 00, then space for 3 bits and then 110. Interestingly, in the previous types, what we have seen, we only had the prefix. But this time we are also having a suffix code. Now the destination register, which is specified by this R, for the code of that we will need to refer to the register code chart. Now what is the code for A? It is 111. So let's have that. Notice 8 bits. So if we group them from the least significant bit towards the most significant bits 4 bits at a time, we will get these 2 nibbles. 1110, as we have already figured out, it is E, and 0011 is 3. So the opcode for MVIA part is 3EH, and since it is 2 byte long, and as you can see, we are providing the data of 8-bit along with the instruction itself, that gives the accumulation of 16 bits. So 8 bits for the mnemonic and 8 bits of data. Shall we do another one? Let's try to figure out the opcode for MVIM, AFH. Now for MVI, as I told you earlier, we have got the prefix suffix code. So we will have 00 and 110. Now the 3 bits in the middle will have to be taken from the register code chart. Now for M, The code is 110, so let's have that. Shall we group them now? So this is 0110, which is 6 in hexadecimal, and this is 0011, which happens to be 3 in both in case of decimal and in hexadecimal. Therefore, the opcode for MVIM AFH is 36H and the data of 8-bit which we are sending with the instruction itself. So, 8 bits and 8 bits, clearly 2 bytes. So this is how we can find out the opcodes for this type MVIR, D8. So I believe now you know how to form the opcodes. We have got the register code chart for this purpose. All we have to know is the code specified for the mnemonics by Intel microprocessor. And don't worry, that is also documented for all the different instructions in the documentation of Intel 8085 microprocessor. So in this session, we covered the topic formation of opcodes. Alright people, that will be all for this session. In the next session, we are going to learn about